How do data types and sizes affect embedded C microcontrollers? Imagine trying to fit a large puzzle into a tiny box. If the pieces are too big, they won't fit, and if they are too small, you might need more pieces to complete the picture. That's similar to how data types and sizes work in embedded C programming for microcontrollers. Every microcontroller has limited memory and processing power, so choosing the right data type is like packing smartly for a trip. In C programming, each data type like char, int, or float takes up a specific amount of memory called bytes. For example, on many 16-bit microcontrollers, an int usually takes up 2 bytes and can hold values from -32,678 to +32,677. A char, which is 1 byte, can store values from -128 to +127 or from 0 to 255 if unsigned. The size depends on the microcontroller's architecture and the compiler used. Microcontrollers come in different architectures, such as 8-bit, 16-bit, and 32-bit. The word size of the processor, which is how much data it naturally handles at once, affects how big or small data types are. On an 8-bit microcontroller, a char and an int are both usually 1 byte. But on a 32-bit microcontroller, an int often takes 4 bytes. Using data types that match the processor's word size makes your code run faster and more efficiently. Memory is precious in embedded systems. Larger data types like long integers or floating point numbers take up more space. If you only need to store small numbers, using a smaller data type like unsigned char saves memory. For example, if you are storing sensor readings that only go up to 255, using an unsigned char instead of an int can free up space for other variables or code. Processing speed and power consumption are also affected by data types. When the data type matches the microcontroller's word size, the processor can handle it in a single instruction cycle. If you use a larger data type than the processor's native size, it might need extra instructions, which takes more time and uses more power. For instance, a 32-bit microcontroller can process 32-bit integers quickly, but handling 8-bit integers might requiring more steps. You can also modify data types with qualifiers like signed, unsigned, short, or long. These change the size and range of values you can store. For example, an unsigned int can only store positive numbers but can go up to 65,535. A long int can hold even larger numbers, which is useful if your application needs to process big data. Different compilers and microcontroller types can have varying sizes for the same data type. To keep your code portable and predictable, it's best to use fixed-width types like uint8_t or int16_t from the stdint.h library. These types guarantee the size regardless of the platform. In real-world applications, choosing the right data type matters a lot. For example, storing small sensor data with a char saves memory. When communicating with other devices, data types must match protocol specifications for correct data exchange. Timers and counters need proper integer sizes to avoid overflow. Floating point numbers are often avoided in low-resource microcontrollers because they need more memory and processing power. In summary, selecting the correct data types and sizes in embedded C impacts how much memory your program uses, how fast it runs, and how efficiently it consumes power. Understanding your microcontroller's architecture and your application's needs helps you make the best choices. It's like packing a suitcase with just the right amount of clothes, enough to get the job done without overloading.